kimliğe giriş sunumlarını yapmak üzere Mike Lodder sahnede. I would like to invite Mr. Mike Lodder. Alkışlarınızla efendim. Sunumlarımıza devam ediyoruz. Evet, yeniden hatırlatalım. Dolmabahçe Salonu'nda sunumlar olacak. İkinci katta bulunan Marmara Salonu'nda da yine eğitimler verilecek. Michael Herman ve Mike Lodder eğitim veriyor olacak. Ama şimdi Mike Lodder'ın bir sunumu var. Bu salonda sunumlara devam ediyoruz.
I don't have. Now let's see if I can get, there we go. Technical difficulties. The wonderful world we live in. Hello, everybody. I'm Mike Lodder. I work at the Sovereign Foundation. Phil and I tagged along here together. So I'm going to be talking about a little more in-depth and a little more technical than both Professor Chadwick and Phil went into. and how all of that system works. I don't know how Professor Chadwick's system works, but Sovereign's based on 3 different Hyperledger projects. Hyperledger Ursa, which functions as the cryptographic layer, Indy, which is the identity blockchain layer, and Aries, which provides a lot of the messaging and the agent layer. So just kind of a top-level layer of how that works. We said people hold physical credentials in the physical world, and then these get verified somehow by someone in our world. They look at a picture, they scan a barcode, or they just look at it and say that looks good enough, and then they move on. But the main thing they're checking is that these aren't forged and they're still legit. They haven't been revoked. Okay? So we've talked about these 3 parties that are involved. There's issuers, there's holders, and then there's verifiers. And there has to be some sort of trust established between the verifiers and issuers for me as a person to be able to use these credentials, right? Okay, so how Sovereign works is we take what this physical world and how that works, and we apply it to the digital realm. So with the same infrastructure. So what issuers can do is they can publish this information on Sovereign. And what this does is this allows the verifier and the holder to look up stuff on Sovereign about the issuer, and it will enable them to know, okay, this is what the issuer said, the issuer signed this, therefore I can trust these keys, and then we can verify them, we can receive them, and the issuer, all they have to do is put their cryptographic stuff on the blockchain. I'm not going to go into exactly what that all looks like, but it's just the public information. This private material that Professor Chadwick was talking about doesn't go on there. That would be really bad if it did. So the other cool thing we can do with a digital world is we don't have to show everything every time. If you think about it, if I have a digital or a physical driver's license, when I hand that to somebody or a government ID, they see everything that's on there. They don't always need everything. They only want a subset of that information, enough to do what they need to do and nothing else, which really is helpful for GDPR. So you can think about with an identification card that has your name and address and a birth date on it. If I'm going in somewhere where they're just checking a box to say, is he old enough? Well, then that's all the information I should have to present and nothing else, which is really cool. We can't do that very easily in the physical world, but in the digital world, there's technology and techniques that enable this to happen. So we kind of call these information hiding techniques that also allows us to have correlation reductions. So if I want to present to the same person, they know I'm the same person each time I come, but to everybody else, it looks completely different. This is how we hide correlation. So if I present to Google each time, Google knows I'm the same person, but let's say someone was watching everything that I'm doing, they wouldn't be able to tell. It looks different every time. And also these techniques also don't change if that the data is valid or not. It's the same data, we're just reducing it and making it selectively disclosed. That's what we call it. Where I take something where I have 10 attributes, I'm only going to show 2 of them, or maybe some other subset of them, and we use what are called zero-knowledge proofs. Some of you may be familiar with this, so forgive me for covering this for those that do not. But a zero-knowledge proof is a way to prove a specific statement and only that statement without revealing anything else about it, which is really cool. So with Hyperledger Indy, this is a blockchain that was specifically designed for decentralized identity. Not tokens or anything else, but for identity. So issuers can write all the information that they need to the blockchain, and it serves as a public oracle for people to go look up that information just for verifiable credentials, nothing else. So the only one who needs to really write anything to Hyperledger Indy are the issuers. If you want to be an issuer, you have to be publicly known by something so that you can be trusted by everybody else that's interacting offline. So the only thing that as a credential holder you have to do is to go look it up and see who the issuers are, and the same with the verifiers, nothing else, which makes it really, really small and compact. So Sovereign is the largest deployment of Indy, but there are others. Another big one is called Kiva. They use Indy as their identity layer, but their primary purpose is microloans. Okay, but there's other deployments as well. I don't know all of them, but if you're interested, that's where the code is at those links and how you want to get started on this. Okay, so this is exactly what Hyperledger Indy stores. We have to know who the issuers are, and we've talked about what a decentralized identifier is. So the issuer has to publish that on the blockchain. So you know who they are. And then we talk about a credential schema. This is exactly what information is going in a credential, what it looks like. So the first attribute might be a name. The second one might be an address, a date of birth, anything else that might be necessary. We also talk about an attribute encoding. So I can't just say your birthday is this specific format. What if I want to encode it as the number of days since some particular year, or I want to encode it in an entirely different format? How is that standardized? That's necessary. You need to know that. So that kind of information goes on there. Also, the public keys, just the public keys. That way they can verify that these credentials have actually been signed by that particular issuer. Now, revocation registry is how we can check whether this credential has been revoked or not, and any material associated with that. So when you go to present, a verifier can go look it up and say, has it been signed by this issuer, and has it been revoked or not? That way, the public key checks that it's not forged, and the revocation registry checks that it's still valid. And then we have this idea. We kind of talked about standardizing how a credential would look like, but what about a presentation? How do those look? We don't want all of these custom formats. These are mostly offline, but there might be standard presentations that we want to use. Like when you go to the airport, what does that look like for your passport? What information is necessary for each government to know for you to enter? Well, that might be public information, and it's the same most of the time or every time. Therefore, let's just go ahead and put those presentation descriptions on the blockchain so that they can be reused for others. So this is so we can standardize and make those common. Okay, so what is Hyperledger Aries? Aries was born out of the idea that we've noticed a lot of common patterns when you're interacting with different and various blockchains. And so we decided to make it its own project. So it was born out of Indy, and now it's meant to be blockchain agnostic and handle basically the messaging layer, DID resolution, key management, messaging, all of those types of things. That's the goal of Aries. And you can basically build what you want for any blockchain or multiple blockchains with this toolkit. It's still in active development, but it's very active. In fact, the community of Aries has outgrown Indy in many ways. So if you combine the two, what you can do with it is actually quite cool. We talked about how, well, what if I have different credentials from different places? What Phil didn't get to show you was if I have a credential from my university and I have a credential from my bank, is it possible that I could use both of those to fulfill some request from a verifier? We can do that with zero-knowledge proofs and presentations. We can combine credentials so I could use 2 or 3 or 10 to fulfill this request from various things, which is actually quite awesome, because then if there is one particular issuer that's being difficult and they don't want to give it to you, you can go to get multiple credentials from 3 or 4 others and still be able to present valid information that you might have gotten from that one, which is quite cool. So Aries has standards for requesting credentials, presenting them, sending just a generic message, or getting a credential, revoking them. And Professor Chadwick talked about FIDO was one way you could do this, but Aries is another place where we're standardizing, and it's an integral part of the W3C community for these protocols for presenting and getting credentials and how those look like. So if you're interested in participating in that work, that's where Aries is useful. Okay, so what is Ursa? Ursa is if you just want to do the cool crypto stuff and you don't want any of that stuff up above, just go right into the crypto code. That's what Ursa is for. It's so that all projects that ever want to do zero-knowledge proofs or any of the other fancy crypto signing and basic capabilities, you can go straight to Ursa and get all that nifty cool stuff. So the reason we did this is creating just all of your code from scratch is usually a bad idea, but crypto is even worse. It's harder to get right. So this is a common joke in the crypto world that people say, well, this is random enough, just return 4 with dice. So the great thing about Ursa is we have a lot of cryptographers and crypto engineers that specialize in this area that review all the code we write and any of the proposed algorithms to make sure that they're secure. So there's actually 2 parts to it. There's the first one, which we call libUrsa, which handles your basic common crypto primitives that you would think of that encrypt, hash, sign, key exchange, and even some hardware integration. And then in combination with IBM Zurich and Dfinity Group, we've come up with what's called libZmix. Zmix is basically I want to describe these proofs, and I have all of these building blocks for doing zero-knowledge proofs, and Zmix will generate the proof for you. So we have a bunch of zero-knowledge proof primitives built into that library, and they're still being greatly expanded. So quick caveat about zero-knowledge proofs. It's a lot like the game of 20 questions, where if I keep asking you questions over and over and over again about the same attribute, I can eventually guess what it is. The whole idea is to hide those attributes and only reveal what is absolutely necessary. So if you keep asking a question about your age, like let's say, are you over 21? But what if you're less than 23? And if you answer both of those in the affirmative, then I guess I just figured out what your age was. So you have to be careful about revealing too much information. But the great thing about zero-knowledge proofs is they definitely allow you to hide things. So here's what you can actually do with those right now. You can prove that 2 things are equal, which is actually quite cool because you can say, is your first name Mike? And the answer is yes or no. And that way I didn't reveal what my first name was unless it was my first name. I can actually do the opposite of that and say, make sure that your first name is not David or not Phil. Then there's this other idea of I would just want to prove I'm over a certain age limit, or I want to prove as a business that my debt-to-income ratio is less than a certain threshold or is greater than a certain threshold. I could do that with actually revealing those numbers, and it just returns a true or false statement. A set membership is interesting. This is actually how we do revocation to prevent correlation. So I basically, with every credential, we can tag it with a credential identifier, usually done by the issuer, so that if they can detect that abuse is happening, they can revoke it. Or let's say they issued the credential with bad data in it, like they wrote the wrong name in it or they misspelled it. So they just have to revoke it and give you a new one. Well, the great thing about a set membership proof is I can prove that it's not revoked without revealing which one it is. I could also do that with some of the other attributes. I could say this is one of these 10 values, but I'm not going to tell you which one. It's just one of those 10, which is really cool. So you have what I call a static set, which is kind of like an enumeration, or a dynamic set that's constantly growing or changing. And with set membership, you could also think, I want to prove that my device was authorized by me, and that way if it's ever stolen, I might have some backup system in place that I could revoke the device, and the attacker would never know. And then the rest of the attributes, we just hide them. You just prove that you haven't changed them and that you know what those values are. That's important, because otherwise they're forgeable. So we don't want to do that. Some other things I was talking about was access controller authorization. You might think, are you on the no-fly list because you've done something malicious? This way I don't even have to add anything to the credential. I just check that some certain attributes are not in the blacklist, and if they're not, then I'm good to go. Or the reverse could be true. You could do this for access control to your system, right? I take my bank credential, I go buy something, and they'll let me buy it if I'm in good standing or not, or they'll let me access something. This can happen a lot in the enterprise environment, right? Are you authorized to access these certain resources, yes or no? All they have to do is change these lists, and that you just have to prove that you're in those lists or not. Delegation is a very powerful tool as well. You can think about when you go to rent a car, you're not actually purchasing the car, you're being delegated the right to drive it for a certain period of time, and then when that time limit's up, they just revoke it. So we have that capability right now that you can do, where you can delegate, and you can even sub-delegate. You can make it so that no one else can delegate. You could revoke that delegation. It's quite cool, and all you have to do is prove that you've received delegation, and you don't even have to tell by whom. Vouchers is an interesting use of credentials or verifiable credentials. I only want to use it once. Maybe I don't want to reveal which one is mine. I just have a valid ticket to the concert. Registration, I want to make sure you've enrolled, but I want to make sure you only enrolled once without revealing which one of you was enrolled. Now, if you're one of the first ones to enroll, then you're not really hiding a whole lot, but once there gets to be a lot, that becomes very helpful. And then there's cases where transferability becomes handy. You can think that's exactly what tokens are. Tokens are just transferring credentials to another person, and they transfer this value. But there might be other cases where you're transferring ownership of something to somebody else. You can do that. Any questions? Chirping birds. Yeah, go ahead. Can you speak a little louder? Or out? Yeah, have a microphone.
So if you have to prove that you are over 18, then what technique you are using? Are you using selective disclosure, or that's really zero knowledge proof?
Okay, so you're actually using both. So selective disclosure is taking a verifiable credential of, say, 10 attributes and hiding most of them, or selective ones. Then what you're doing is you're attaching to it a zero knowledge proof that says this date of birth is the same date of birth in the credential, but I'm also proving it's over 18. So you're doing two proofs. This gentleman over here has got a question.
Thank you. I'm Khalid from Tyken. I think you didn't mention range proofs.
Which ones?
Range proofs. Like there is a range proof within zero knowledge proofs.
Yes.
Yeah. If you could elaborate on that. And I have another question as well. For our current project, we're using voucher systems where we allocate tokens to a certain person, but these people need to be identified first. So how can we stop let's say, prevent that the data is correlatable?
Okay, so your first question was about range proofs, and then the second one is, with vouchers, I want to prevent that they're correlatable.
Yeah.
Is that the next question?
Yeah, so people are being identified first, and then there is a token allocated to their wallet to use for, let's say, getting food or something else.
So correlation is a difficult question, so let me answer the first one. So the first one about range proofs, yes, you can do that now, where that's basically what the date of birth thing was. I want to prove you're over 18 because my date of birth was encoded as the number of days since 1900. So I calculate what that number would be now. I can check that it's greater than or less than that certain range. I could also do multiple things. I can say, make sure you're over 21, but you're less than 55. If you're going to be an airplane pilot, they have age restrictions. So you can't be over a certain limit, but you can't be under a certain limit either. That's possible. Now, for correlation with vouchers. Correlated in what way? That it's the same person? So let me think about that for a minute. So with vouchers and registration, you can, one technique might be to have a registry of these are the ones that are outstanding or unspent, and you have to prove that you're in that, therefore you're not correlated, and once it's removed from that system, then you could say, well, this person just spent, right? So you could also remove a bunch at the same time and say, well, I don't know which one he was out of these 50 that were just removed. That's one way to do it, is have a slight delay, if you're willing to tolerate it, until there's more than just one. Because if you just have one, then yeah, correlation happens. But that's totally possible with these, but it's up to you as an implementer to design for that. Any other questions?
Okay, thank you very much for your speech. Alkışlarla uğurlayalım bu sunumu için. Mike Lodder'a teşekkür ediyoruz ve bir diğer sunumla devam edeceğiz. Dijital kimlik, blok zincir ve kişisel verilerin korunması kanununa uyum üzerine hukuki düşünceler başlığıyla Solak Partners